The essence of federated learning is the ability to train models in parallel on a wide number of machines. But in order to do this, we first need the ability to tell remote machines to execute operations required for deep learning. Thus, instead of using torch tensors locally, we're now going to work with pointers to tensors that exist on a different machine. However, in order to do this, we first need to know what is an interface to another machine really look like. Fortunately, PySyft creates this interface for us through something called a worker. The first thing we're going to create is called a virtual worker. And what this really does is it just simulates the interface that we might have to another machine. Now, a worker in the context of PySyft really is a new kind of primitive. So whereas PyTorch and TensorFlow are both solely focused around the primitive type, the core type of a tensor, with PySyft, we have sort of tensors that are owned by a variety of different machines or a variety of different workers. And so these workers form another core primitive of the framework. Now, a worker is really quite something simple. It's just a collection of objects. In most cases, these objects will be simple tensors that we're trying to perform operations with, but sometimes they can be other kinds of objects as well. Let's try it out. So if I create a little bit of data here, I can then use the first piece of functionality that PySyft added to PyTorch and send this data to Bob. And now if I look inside of Bob's objects collection, I see indeed the tensor that I had originally initialized was actually sent to Bob. But now this begs the question, what was returned when I sent it? This is where PySyft's power really starts to be shown for the first time. What was returned to me was a pointer to the remote object. Now, a pointer is actually a kind of tensor, and it has the full tensor API at its disposal. However, instead of actually executing these commands locally like a normal tensor would, each command is serialized to a simple sort of JSON or tuple format, sent to Bob, and then Bob executes it on our behalf and returns to us a pointer to the new object. Now, there are a few assets on these pointers that are required in order for this to be doable. The first one is location. So if we go x.location, we see that this pointer is pointing towards Bob. If we actually go check and see, is x.location equal to Bob? The answer is true. X has an ID at location, and then X has an ID as well. And these three pieces of metadata actually allow X to communicate with Bob. So whenever you try to perform a command, say addition or subtraction using X, it's going to send a message to self.location and say, hey, Bob, find the tensor that has this particular ID and execute the command that I would like for you to execute. There's one more attribute that all tensors in PySyft have, which is an owner. In this case, because we are the client, the owner defaults to be me. And this reveals one other worker which was created without our knowledge. And this was created when we first imported and hooked PySyft into PyTorch. And this is a worker called local worker. So you see, whenever we actually communicate with a remote machine, what we're really doing whenever we execute a command regarding X is we're saying, hey, local worker, contact Bob and tell him to do this, right? So there's a connection between local worker and Bob and any other workers that sort of learn about each other. So let's execute one of those commands now. So if I go x.get, just to remind you that X is a pointer, then I will actually get the information back from Bob. And if I go and look in Bob objects, you'll see that Bob no longer has any tensors anymore. So as you can see, this is a very powerful interface that allows us to do everything that PyTorch can normally do, but we can execute it on arbitrary remote machines. And we will see that this pointer interface actually allows us to coordinate large complex protocols such as federated learning with ease. And in the next section, what I'd like for you to do is play around with this. So what I would first like you to do is to extend this use of send and instead create two workers. So I want you to create a Bob worker and an Alice worker. And then I want you to both send and get a tensor to both of those workers simultaneously, right? So instead of just calling .send, you're going to call .send Bob and Alice. All right, so go ahead and take a shot at that project, get used to this interface, get PySyft imported into your system, and in the next video, I will show you how I would execute this program.